Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for number system workshop, and I'm sure you might have revised the previous three sessions of the sequence. So let's begin this session. Have your paper and pen with you and just try to understand everything that we are going to discuss in this session. Okay, so let's begin. Now, here I would like to discuss one more concept. Though I have already discussed in that concept in the basic sessions. Still, just we have a quick recap. A raised to n plus b raised to n is divisible by a plus b if n is odd. The practical example that you can see is a cube plus b cube. That's divisible by a plus b, a square minus ab plus b square, right? So that's the factorization of a cube plus b cube contains a plus b, right? So if n is odd, similarly a5 plus b5, definitely it will be having a factor as a plus b, right? What the other factor that we cannot comment as of now, but definitely a plus b will be one factor, right? Similarly, if a raised to n minus b raised to n is divisible by a plus b and a minus b both, right? If n is even. Again, the practical example is when n is equal to 2. A square minus b square has factor a minus b, a plus b. Similarly, a4 minus b4 will be having these two factors. Some other factors will be there, but for sure these two factors will be there, right? So you should be knowing this. Apart from that, a raised to n plus b raised to n will never be divisible by a plus b if n is even. Obviously, because what happens? A square plus b square, right? We can't have any factor. This term can never be 0. In no case it will be 0. Okay, whether a or b are negative or positive. Okay, so a raised to n plus b raised to n is divisible by a plus b only if n is odd. A raised to n minus b raised to n is divisible by a plus b and a minus b both if n is even, right? Similarly, a raised to n minus b raised to n is divisible by a minus b if n is odd. Okay. Similar, I just can take the example of a cube minus b cube. So that's a minus b, a square plus ab plus b square. So a cube minus b cube is divisible by a minus b, right? So the three things are there: a raised to n plus b raised to n, a raised to n minus b raised to n for even and odd numbers. Okay, when n is even or odd. So if you are confused at any stage, just take the minimal value of n. That is for even, just take 2, and for odd, just take 3. So you'll be able to generalize that. Okay. Now I take one example over here. Suppose I have an expression x is equal to 1 raised to 1995 plus 2 raised to 1995, and the sequence is going till 1996 raised to 1995, right? Now, if this expression is divided by 1997, remainder is what? Right? Now, this is going to be, I mean to say, seems to be a tedious one, but it's very easy if we are basically if we are clear with the basic concepts. As we have just discussed, a raised to n plus b raised to n will be divisible by a plus b if n is odd, right? So since there are 1996 terms, right, that means half of them, that means they are divisible by 2, right? Now what is happening? 1 raised to 1995 and 1996 raised to 1995. If we club both of them, what will happen? The addition will be divisible by 1 plus 1996, because this plus this, right? A plus b, that means a raised to n plus b raised to n, where n is odd, right? So 1 raised to 1995 plus 1996 raised to 1995 will be divisible by 1 plus 1996, that is 1997, right? So these two terms are divisible. Similarly, here we must be having 1995 raised to 1995. So with this 2 and that 1995 raised to 1995, further 2 plus 1995, that comes to 1997. So further they will be divisible, right? So all the terms will be making combinations. Since there are even number of terms, so each and every term will be making combination with the other one, right? So in each case the remainder will be 0. So finally the remainder will be 0, right? No paperwork is required at all. You just have to see the problem, just recall the concept. A cube plus b cube is divisible by a plus b when a raised to n plus b raised to n is divisible by a plus b if n is odd, right? I hope you are getting it. Now I have this question. Here x, y, z are integers, and this expression if divided by 7, remainder is what, that we have to find out. So whenever these sort of questions are asked, friends, just put up the comfortable values of x, y, z, right? Do not try to interpret anything because that will be really time consuming. So do take the comfortable values of x, y and z, right? Never ever take the values as 0, any of them, right? So I take x, y, z as 1, 2, 3, most comfortable, easiest value, right? And if you take them distinguished from each other, then what will happen? You will not be making mistake, right? If the two are same, then what will be happening? You'll be getting a 0, right? So take them different from each other. After that, if you put up the value, that is 6, x cube minus y cube. What y cube is? 8, x cube is 1. So x cube minus y cube, the difference is 7, right? So maybe positive, maybe negative, but the difference is 7. So we already got 7 as factor of this expression, right? Now if this expression is divided by 7, since this expression is multiple of 7, if we divide it by 7, the remainder will be 0, obviously. Okay, now if this expression is producing 0 as remainder, if we put the value of x, y, z as 1, 2, 3, that means we can generalize that. Okay, because if it is true for any one of the one set of the values, then it will be true for other set of values as well, right? No need to check further. I hope you are getting me. So answer to this problem will be C. Now we are given P is a prime number greater than 3, right? Now what will be the remainder if P square is divided by 12? I've already discussed this problem in our basic session, but once again just making a quick recap over here. See, any prime number greater than 3 is always in 6x plus 1 or minus 1 format, any prime number. So since P is greater than 3, that means it should be in the form of 6x plus minus 1 format, right? Now P square will be what? We can make it square of this. So that's 36x square plus minus 12x and plus 1, right? Now if you divide this expression by 12, what will be the remainder? This expression is multiple of 12, this expression is multiple of 12, only 1 is left. So the remainder will be 1 only. Okay, so if you know this property, P is always in 6x plus minus 1 format, that means it is either 1 less or 1 more than the multiple of 6, then this can be done very easily. Else there is no method to solve this problem. Okay, I hope you are clear. Now we have this question. 7 raised to 119 plus 1 is divisible by. Now 1 can be written as 1 raised to 119, right? So since the power is odd, we have the positive sign, so this number will be definitely divisible by 7 plus 1, right? 7 raised to n plus 1 raised to n will be divisible by 7 plus 1 if n is odd, right? So here n is odd, so that will be divisible by 7 plus 1, that's 8. So if this expression is divisible by 8, then that means it is divisible by 2 also, 4 also, 8 also. Now we have to check for 6. Okay, now for 6 what we can do is we can directly divide this expression by 6. 7 can be written as 6 plus 1 raised to 119. Okay, Now if we divide this expression by 6, what is the remainder that we are going to get? That's 1 raised to 119, that means 1. So this 1 plus 1, the remainder will be 2. That means this expression is not at all divisible by 6. Okay, I hope you are getting me. Similarly, suppose I have an expression 25 raised to x plus 1. Now if I have to divide this by 13, remainder is what? Right? So let's see whether it depends upon x or not. Now 25, closer to 25 we have a number 26, that is multiple of 13. So that's 26 minus 1 raised to x plus 1. Right? Now what is happening over here? This expression I have written like this. So if we divide this expression by 13, the remainder will be minus 1 raised to x plus 1. Right? Now if I get minus 1 as a remainder over here, then minus 1 plus 1, it will be 0. Right? And if I have remainder as plus 1, then the remainder, overall remainder will be 2. Right? So if x is even, what will happen? If x is even, this minus 1 will be converted to 1 and this 1, 2 will be the remainder. Right? And if x is odd, then what will happen? X is odd, then minus 1 raised to odd, that will be converted to minus 1 and then plus 1. Then it is 0. Right? So 25 raised to x plus 1 will be divisible by 13 if x is odd. Getting my point? And 25 raised to x plus 1 will not be divisible by 13 if x is even. Pretty simple. Okay? Now instead of 25, suppose I have 27. Right? Then what will happen? This will be the situation. Okay, 26 plus 1 raised to. So in that case, what will happen? We'll be getting 1 raised to x plus 1. Now whether 1 is odd or even, right, doesn't matter, because if this x is odd or even, in both the cases we'll be getting 2 as the remainder. Okay, so 27 raised to x plus 1, in no case it will be divisible by 13. Okay, just be clear about it, because in that case it will be this. So x is odd or even, the remainder will be 2 only. Okay, so you should be clear about this. You can make some of the expressions on your own and practice with them. Now this expression is not divisible by. Further, we have 21, 21, that means a raised to n plus b raised to n, where n is odd. That means this expression will be divisible by 17 plus 19, that's 36. Right? So if it is divisible by 36, yes. If we have 9 and 18 as factor of 36. So if it is divisible by 36, obviously it will be divisible by 9 and 18 both. Now we have to check for 8. Right? Now how do we check? 17 can be written as 16 plus 1 raised to 21. So the remainder, if 17 raised to 21 is divided by 8, will be 1. Here 19, that is 16 plus 3 raised to 21. So I write 3 raised to 21. Okay. The total remainder, if we divide it by 8, will be getting this. Okay. Now we have to further reduce it. So 3 raised to 21 can be written as 3 raised to 20 into 3. So 3 raised to 20 can be written as 9 raised to 10, and that is 3. Now 9 raised to 10, that can be written as 8 plus 1 raised to 10. Right? So that the remainder will be 1 only. That is 1 raised to 10, that's 1. So the final remainder will be 1 into 3, 3 plus 1, 4. So if this expression is divided by 8, the remainder will be 4. I have calculated that. Though it is not needed, but I thought let me complete it. It's definitely not divisible by 8. Okay, I hope you are clear. Now I have a classic question with me. When x is divided by 6, remainder is 3, right? So if x raised to 4 plus x cube plus x square plus x plus 1 is divided by 6, remainder is what? See, it's a classic question, important as well. Listen to me very carefully. In the previous session itself, I have told you that if precisely any odd multiple of 3, just listen to me carefully, any odd multiple of 3 gives remainder as 3 if divided by 6. Okay. So if x is divided by 6, remainder is 3, that means x is odd multiple of 3, right? Multiple of 3, but it is odd multiple of 3. Now, if you know this concept, then no paperwork is required at all, right? Now, this odd multiple of 3, if it is raised to power 4, doesn't matter. Still, it will be an odd multiple of 3 because odd number raised to any power will produce an odd number, right? And if it is multiple of 3, still it will produce the multiple of 3, right? So, x raised to 4 will also be odd multiple of 3. So, here if this term is divided by 6, the remainder will be 3, right? This term is divided by 6, still the remainder will be 3. This term is divided by 6, still the remainder will be 3. And here we already know that's 3. So this is the final remainder. This is 6 gone, 6 gone. So we are left with 1, right? So you see, if you are conceptually clear that with this thing, any odd multiple of 3 gives remainder as 3 if divided by 6. Same we have applied over here, and the question can be solved in just less than 20 seconds. Okay, so final remainder is 1. Okay, good one. And friends, this we can prove algebraically, right? I take an odd multiple of 3. I have a number 3. Then odd multiple, that means the number should be in 2x plus 1 format, right? So this complete number is odd multiple of 3. If you expand this, you'll be getting 6x plus 3, right? So while divided by 3, the remainder will be 3 only. While divided by 6, the remainder will be 3 only, right? So any odd multiple of 3 gives remainder as 3 if divided by 6, okay? And now we have this question here. 2x cube plus px square plus qx plus 12 is multiple of x square minus 4, or we can say x square minus 4 is a factor of this, right? And we have to find out the value of p and q. To attend this question, friends, there are two ways. One of the way is, see, x square minus 4 is factor of this. That means if you put x is equal to 2 or minus 2, the value of this expression will be 0. So you'll be getting two equations. If you put x as 2 and x as minus 2, then you can solve them by simultaneous equation method, and you can get the value of p and q. So that's like simple method. The other method is, if you are clear with the basics of equation that I've already discussed in the basic algebraic sessions. So if you are clear with the basics of equation, you'll be knowing that constant term, see the two factors we know, that 2 minus 2, third factor I assume to be m, right? Now sum of these three, that is this plus this plus this, should be equal to or I can say sum of coefficient, sum of roots is equal to coefficient of x square in negative, right, in cubic equation. Coefficient of x square in negative divided by coefficient of x cube, right? So that's minus p by 2. Okay, so that's actually 2 minus 2 plus m. So that's m. And product of the roots will be what? 12 by 2, that's 6. And that is actually 2 into minus 2 into m. Right? So constant term is actually product of the roots in negative. So product of the roots is this. So if I make it negative, it will be constant term, right? So m is equal to 3 by 2, right? If you put m as 3 by 2 over here, what will happen? P will be minus 3, right? So we got the value of p, that's minus 3, right? After that, we have to find out the value of q. We have two options for q, 8 or minus 8. So definitely we have to calculate. Now coefficient of x is q, and in the cubic equation, coefficient of x is sum of the roots in pairs, right? I put m as 3 by 2. Quickly make pairs and find out their product and add. So 2 into minus 2, minus 4. Then 2 into 3 by 2, that's 3. Minus 2 into 3 by 2, that's minus 3. So that is actually q by 2, right? So q is actually minus 8. Okay, so without making equations, you can solve the problem if you are clear with the basics of a cubic equation, right? If you are clear, then even you don't have to go this much paperwork. Okay, so that's important concept I have used over here. In the number system topic, I am using the concept of algebra, but that doesn't matter because before attending these workshop you should attend all the basic sessions. Okay, so you'll be clear with even algebra concepts. Let's take the next one. Now friends, we are going to discuss Wilson's remainder theorem. The questions based on Wilson's remainder theorem are asked in CAT examination for 4 to 5 times. So consider to be important one. Now what exactly Wilson's remainder theorem is? See, p minus 1 factorial plus 1 is divisible by p if p is prime number. So the practical application I would like to discuss over here. See, the question says p minus 1 factorial plus 1 is divisible by p. How many values are possible for p if p is say less than 10? Okay, this is the question. Okay, now p minus 1 factorial plus 1 is divisible by p. How many values p can take if p is less than 10, right? Here we are not given p is prime. That is the answer to the problem, right? That p is prime, right? We know Wilson's theorem, p minus 1 factorial plus 1 is divisible by if p is prime, and that we have to put over here. Now less than 10, how many values of p are there? That for that p should be prime, right? So that's 2, 3, 5 and 7. So p can take 4 values, right? So that will be the answer to the question, and instantly you can answer if you know Wilson's theorem. Now suppose I have a question, if 46 factorial is divided by 47, remainder is what? Now 46 factorial is what? 47 minus 1 factorial, right? So 47 minus 1 factorial plus 1 will be divisible by 47, right? So 47 minus 1 factorial plus 1 is actually 47k, but we want the value of this, so that will be 47k minus 1, right? So this expression is actually 47k minus 1. So if you divide this expression, that means this expression, by 47, the remainder will be minus 1, because here it is 47k, so the remainder will be 0. So finally the remainder will be minus 1. That means if this expression is divided by 47, remainder will be minus 1. So positive remainder will be 47 minus 1, that is 46. It is as simple as that, and a simple application of Wilson's theorem. Okay, so I'm sure you are clear with the Wilson's theorem as well. Next thing, in the sequence of this Wilson theorem, see, n minus 1 factorial is divisible by n if n is composite, right? That means 6 factorial will be divisible by 7 factorial will be divisible by 8. Okay, n is 8, so 8 minus 1, 7 factorial is divisible by 8. Okay, similarly other values can also be taken. Now further, if I ask you one question, n minus 1 factorial is divisible by n is less than 10, then how many values can n take, right? The question, n minus 1 factorial is divisible by n, and if n is less than 10, how many values n can take, right? So all the composite numbers less than 10 can be chosen. So make a list: 2, 4, 6, 8 and 9. I'm sorry, cannot choose 2 as prime number. So we have 4 values. In all the 4 cases, n minus 1 factorial is divisible by n. Yes? No, friends. There is an exception to this rule, that is number 4. Okay, the only exception is number 4 out of the entire series, right? 4 minus 1 factorial is not divisible by 4. right? 4 minus 1 factorial is what? 6, and 6 is not divisible by 4. Otherwise, all the remaining these numbers are true for this statement, right? 6 minus 1 factorial, that is 5 factorial, that's 120, perfectly divisible by 6. Then 8 minus 1 factorial, that is 7 factorial, that's 5040, perfectly divisible by 8, right? Similarly, 9 minus 1 factorial, that's 8 factorial, that's perfectly divisible by 9. The only exception to this rule is number 4, right? So if n minus 1 factorial is divisible by n, how many values can n take if n is less than 10? Will not be 4 but 3. But believe me, in options there will be answer as 4 also. Okay, so you have to be careful. 4 is the exception. This 4 is the exception. So you are left with n can take 3 values. Right? 6, 8 and 9. So I hope you are clear with Wilson's theorem and its application. So friends, we have discussed Fermat's theorem, we have discussed Wilson's theorem, right? And in this session we have discussed various concepts also. We did various problems also. I'm sure now you'll be getting the confidence over number system. In the next session, in the next workshop, we'll be taking more problems based on number system, right? So I'll see you in the next session once again. Bye-bye.